Hello, Algebra 2 students, and welcome to 4.6, Imaginary and Complex Numbers. All right, you're going to need your notes. You're going to need a pen or a pencil, and you're definitely going to need a calculator because I'm going to have you plug something in for me because I want you to see what you would get. All right, here we go. Once upon a time, not too long ago. Okay, anyway, a man sits down to solve a quadratic equation. And here's the quadratic equation. X squared plus 10 equals 0. We know it's a quadratic equation because quadratic equations have x squareds. We know that it's an equation because it has an equal sign. All right, so when we go to solve this, how do we solve this equation? Well, we can't factor this because 10 is not a perfect square. So we have to use the method that we were using yesterday, solve by square rooting. So I would subtract 10 from both sides. X squared equals negative 10. Square root both sides. When I square root a squared, x squared, square root it, I get an x. When I square root this side, remember there's two possible answers. So plus or minus the square root of negative 10. Now I want you to plug in the square root of negative 10 in your calculator. What do you get? Yep, you got an undefined. Oh, or maybe you got math error. Or maybe you got no real solution. Okay, or no reals. Okay, but whatever you got, your face probably looked like that. Yeah, because that's what mine did the first time I saw it a long time ago. Well, he felt that same way too. He didn't like what he saw. He said, that makes no solution. So since even his calculator didn't understand negative square roots, hope you're scratching your head at that one. There were no calculators in the 1600s. But anyway, he developed a plan. He invented a new sort of number system, a new type of numbers. They're called imaginary numbers. And it was in the 1600s, and his name was Descartes. Okay, so this is the number system that you've been working with since you were a toddler. Your mom and dad wanted you to be able to count when you were 2. When you started talking, they said, I want you to count. So they started saying 1, 2, 3, 4. You've been working with the real number system since you were a toddler. Literally. We have worked with rationals, irrationals, fractions, decimals, integers, whole numbers, opposite whole numbers. But what you've never seen is this new number system. And this new number system is its own number system, all on its own. And that's the complex number system. Or we can call it imaginary numbers. Okay, so new to you. So this is where you need to start taking notes. What Descartes did is he came up with a way to be able to solve that last problem. He said, there's got to be a way that I can make this work. So what he did is he sat down and he decided that I was going to be equal to the square root of negative 1. So you need to know that. In order to work with imaginary numbers and in this complex number system, you need to know that I is equal to the square root of negative 1. This is necessary for simplifying square roots. We need to know this. Okay? Now, he also said, well, what happens if I take this I equals the square root of negative 1 and I square both sides? If I square both sides, what do I get? Well, this is what I get right here. I get I squared is equal to negative 1. And this is also very important. So star it, highlight it, make it big in your notes. These two are the things that are going to help you work with imaginary numbers. And we use this concept when we are doing operations, like adding, subtracting, multiplying. So when we're simplifying square roots, we need I is equal to the square root of -1. And when we're doing operations, like adding, subtracting, and multiplying, we need I squared equals -1. Okay, so let's do some examples, what Descartes did. Okay, so how do I use I when I rewrite square roots? Remember, I just got done saying that I is equal to the square root of -1. This is what we need for this square root, simplifying our square roots. Well, you should all know how to simplify square roots. We kind of worked with that yesterday. We're going to review it again today, so if you're shaky, it maybe will come to you today. So what we can do is we can take this radicand and we can break it up into two radicals. What times what gives me -25? Well, I know that -1 times 25 gives me -25. Here's where the square root of -1 comes in. Anytime you see a negative, you're going to have the square root of -1. So now, if I were to simplify this or rewrite this in simplest radical form, -1, the square root of -1 is I, and the square root of 25 is 5. And so that is how we can simplify the square root of -25. Okay, let's simplify the square root of -6. Well, it's -1, the square root of that, times the square root of 6. The square root of -1 is I. The square root of -6 is the square root of -6. Now you're probably wondering, why did I put the I here and now all of a sudden I'm putting the I here? Well, when I have a whole number, I like to put that whole number in front of variables. But when I have this, I like to put the I in front of the square root of 6 because if I do this, this is okay, but make sure the I is not under the square root. So I will accept this, and I see this a lot, and sometimes I even write it like this, but make sure that that square root does not go over the I if you're going to write it like that. All right, so let's do another one. The square root of -40. Well, that's the square root of -1. Oh, but 40 can be broken down here. So I can do the square root of -1 times the square root of 4 times the square root of 10. And now I figure out each and every one of these parts. The square root of -1 is I, the square root of 4 is 2, and the square root of 10 cannot be broken down. So I leave it like that. All right, let's try some more. Okay, this one's a little bit different. This has a multiplier out in front of it. Okay, so how do I do this one? I say 5 times, I keep it as a multiplier. The square root of -1 gets me that -1 out of there. Now, what's a perfect square that goes into 48? 16 and 3. All right, so this problem turns into 5 times the square root of -1 times the square root of 16 times the square root of 3. And we can just simplify all of these things. Square root of -1, that's I. Well, this is still 5 times I. Don't change your multiplication signs to any kind of weird positive or negative signs. Times the square root of 16 is 4 times the square root of 3. Now, 5 times I times 4 is 20I square roots of 3. And that would be the simplest form of 5 times the square root of -48. All right, let's do the bottom one. When I have a radical and I have a division sign, I can split that up into square root of -18 and the square root of 4. The square root of 18, well, that's -1 because anytime we have that negative, we can say the square root of -1 times the square root of 9 times the square root of 2 because 9 times 2 is 18 and 9 is a perfect square. The square root of 4, well, yep, you got it, that's 2. Square root of -1, that's I. Okay, that one's going to be I. Square root of 9 is 3, so I'll say 3I times the square root of 2 all over 2. So that's simplifying square roots. Remember, when you're simplifying square roots, you're using I is equal to the square root of negative 1. Now we're going to do some simplifying of complex numbers, but we're going to do the operations, like we're going to multiply and add or subtract, okay? So in this case, this is a distributive property, just like you have been, since middle school. I times 3 is 3i. I times I is I squared. Now remember, when did I tell you you would need to use the other part? Well, that was the I squared equals negative 1. When we do operations, adding, subtracting, we need to use I squared equals negative 1. Because, look at here, we have an I squared. I can use substitution. Okay, I'm going to substitute negative 1 in for I squared. So this becomes 3i plus negative 1. Okay, because I'm substituting that in. So this is 3i minus 1. Now what you need to know is that when we write a complex number, we always put the real part first, and the imaginary part goes second. So I should rewrite this so it says negative 1 plus 3i, because this is the imaginary part, this is the real part. So this is how I would write my problem. Okay, this says 3 plus 2i plus 4 minus 6i. Don't go crazy on me. Take that out and start double distributing. This says add. Add the things that are the same. So just go ahead and rewrite this problem. Distribute the plus 1. Okay. And now add like terms. Add like terms. Okay. Like term, like term. 3 plus 4, 7. 2i minus 6i minus 4i. There's the answer. Okay. Don't get all crazy on me and try to do something crazy by multiplying those. When it says add, literally add the things that look the same. Okay, this says, oh, this one says multiply. So here we can double distribute. 3i times 4. Well, that's 12i. 3i times negative 5i. That's negative 15i squared. 6 times 4, 24. 6 times negative 5i, negative 30i. Okay, now that you double distribute, add like terms. Okay, so we're going to add like terms. Here's 12i and negative 30i. That makes negative 28. Ooh, excuse me. Sorry about that. Negative 18. Let me get my eraser out here. Negative 18i. Okay, negative 18i minus 15i squared plus 24. Okay, here's the problem. We have an I squared. Remember, we have to use substitution. So let's substitute that in there. Negative 18i minus 15 times negative 1 plus 24. Negative 18i plus 15 plus 24. Okay, the real part goes first. So this would be 39 minus 18i. And that would be the answer. Okay, because I'm going to substitute that negative 1 in there. That makes a positive 15. We have a positive 24. That's where I get my 39. And then the negative 18i came from adding like terms, 12i minus 30i. Okay, now let's do one more here. Okay, now I've got a negative sign here. Again, this means subtract. It doesn't mean distribute the negative and then multiply. No. Distribute the negative, but as you're doing it, get rid of the parentheses. Now, add like term. Add like terms. Okay? We've got 6 and negative 5 make 1. And we've got 2i and 4i, which makes 6i. All right. So that's working with I. The adventures of working with complex numbers will continue tomorrow.